Good morning, students. Today's topic of discussion is expert system and applications. The goal of AI is to understand the concept of intelligence and develop an intelligent system. Uh, a, a computer program that exhibits intelligent behavior is called an expert system. For example, if there is a computer system that prescribes medicine based on the symptoms given, there will be user interface where user has to specify what are the symptoms, and then uh, after user submits these details, there is a knowledge base. In from this knowledge base, it deduce some uh, disease. It's like a detector. It detects disease based on the symptoms, and then perhaps give out the disease name or medicine name or whatever. So this is like an expert system which is behaving, um, which is exhibiting intelligent behavior like a human being. When you go to a doctor, this doctor is an intelligent being. Doctor has also got expert knowledge in that area. When patient describes about all the symptoms, doctor would detect the disease and the medicines. So this is one example of an expert system. Nowadays, we can consider there are so many expert systems available. For example, there is an app, mobile app, an Android app that asks you questions and gives the response in the form of your mental state, whether whether you are in a happy state or in a sad state, based on the responses that it receives from the user. This app would give out the mood of the person. That is also considered to be an expert system, as it is exhibiting intelligent behavior. And this expert system are also referred to as knowledge based expert system. Why they are referred to as knowledge based expert system? Because it has got knowledge associated with it. That system would not give the response based on you know nothing. It gives response based on the knowledge, and that knowledge is stored in the form of knowledge base, like a database. In database, you find the tables. In the tables, you have all the um, data available related to a particular entity, a particular system. For example, if we have a database system of students, MCA students, MCA 1, 2, uh, this database would contain all the details related to these students. For instance, their personal details like their name, address, mobile number, father name, date of birth, and so on, and their um, academic details, for instance, their marks, their attendance, their assignment submission status, and all the details. So, what is this? This well, this is known as students database. All right, students database. When we talk with respect to AI system, uh, consider that that expert system is a medical expert system. That medical expert system would have a knowledge base. That knowledge base contains every information related to that particular area. Example, there is a system called MySyn. This is the name of the AI system. Like we find now names of the voice assistants like Siri, Cortana, Google Assistant. These are the names of the voice assistants that are supported in mobile phones systems. Likewise, there is a system known as MySyn. All right, this was developed by leveraging the expert knowledge of best diagnosticians. Who are diagnosticians? One who detect the diseases, who diagnose is nothing but identifying of bacterial infections. There are different types of infections. This particular system mycin was developed in order to have expert information uh, on bacterial infections. And that mycin system was found to be better than average clinicians. Average clinician means you're not an expert of bacterial infection, rather a clinician, a general doctor. This system was found to be better than an average clinician. This is another example. Well, this example is about developing a chemical refinery um, in knowledge base. This chemical refinery knowledge base was developed uh, by harnessing the expertise of an experienced retired employee. There was a experienced engineer who was retired, and that company used to gain lot of information from that engineer. And when that engineer is no longer working for that company could face problems. So to avoid those problems, what company did was they created uh, a system. In that system, they have created and they have stored all the knowledge of the experienced retired employee. What are the phases in building expert systems? Well, it's not an easy task to build an expert system. We can see here that it begins with identification phase. In this phase, the knowledge engineer determines important features of the problem with the help of human domain expert. Again, consider that mycin example. Human domain expert in that would be the best diagnosticians, diagnosticians, and those human domain experts would assist this knowledge engineer. Knowledge engineer is the one who is developing this AI expert system. They sit together and they They determine the type and scope of the problem, the kind of resources required, goal and objective of the expert system. This is first identification phase. Second one, conceptualization phase. Knowledge engineer and domain expert. In this, decide the concepts, relations, control mechanisms needed to describe the problem solving method. What are the concepts, what are the relations between them, and what is the control mechanism? And at this stage, the issue of granularity is also addressed. Issue of granularity is about having at which level the information is to be taken from the domain expert and feed it into the expert system in that level of details. And the third step was formalization phase. This phase involves expressing the key concepts and relations. Out of all the identified concepts and relations, what are the key concepts and relations in the you know to be developed expert system? If there is an analogy between that ER diagrams and this expert system, database designing and expert system, the process of database design also begins with the identification phase, followed by the ER modeling. From ER modeling, uh, tables are created. No, normalization happens. No, what I said is right. First phase is identification. Second is ER modeling. Third one is uh, mapping ER to tables. Fourth one is normalization. Here as well, uh, it is with respect to the knowledge of data structures, inference rules, control strategies, language required for implementation. All that is determined in formalization phase. Everything is formalized, followed by the implementation phase. This deals with the converting the formalized knowledge into a working computer program. It is called as the prototype of the whole system. The fifth phase is testing phase. This involves evaluating the performance and the utility of the prototype system that was developed in phase 4. And also feedback is provided, which helps the knowledge engineer to revise it if required. What is knowledge engineering? Well, the whole process of building an expert system is also referred to as knowledge engineering. Why it is referred to as knowledge engineering? It is all about gaining the knowledge from the domain expert, creating a database, a base, knowledge base, and then linking it with the user interface and testing it. So from the phases of the expert system building, also we know that the the primary component in any expert system is knowledge. Therefore, it is often referred to as knowledge engineering. And the person, an expert who's who does this knowledge engineering, which means extracting the knowledge, um, coding the knowledge, representing the knowledge, That all is done by this knowledge. Actually, what is done by this knowledge engineer? Knowledge engineer tasks and responsibilities involve ensuring that the computer has all the knowledge needed to solve a problem. Okay, choosing one or more forms to represent the required knowledge. We learned different forms to represent the knowledge. Ensuring that computer can use the knowledge efficiently. Using some of the reasoning methods. All right. These are the tasks of knowledge engineer. Mm, the figure 8.1 shows the interaction between knowledge engineer and domain expert for creating an expert system. In the middle lies the knowledge engineer who is building expert system by drawing the knowledge from the domain expert by posing relevant queries or questions to the domain expert and taking the answers or solutions from the domain expert, representing in one of the forms and developing a reasoning system. All right. Knowledge representation. How is knowledge represented? Well, knowledge could be represented in various forms. For instance, you have simple production rules form where you have if person has cold and if the patient has cough and if these are known as production rules. All right, and these rules that contains information about a particular domain is known as this knowledge base. Knowledge base is a collection of domain knowledge. And inference engine uh, obtains the knowledge or the inferences or conclusions or um, derivatives or deriving of new knowledge or information from this knowledge base could be done through production rules. Okay, another way to represent expert system is through frame semantic networks, extended semantic networks. Expert system architecture. Expert system architecture is shown in this figure. This is the architecture of an expert system. It has got various components. There is a user who interacts with the expert system, and this user interacts through user interface. If it is a mycin expert system which diagnose bacterial infections, then this user interface is provided to the user to specify all the symptoms and laboratory test results to the expert system. In other words, expert system takes the data from user through this user interface. This data is given to this dynamic database, which is the working memory. Dynamic database is a part of export system um, that is developing in the sense that it takes the user interface and takes the uh, data from the static database, and then creates a dynamic database that includes both the user queries at the runtime, as well as the rules or the knowledge that is created as a static database. And this, the whole component which encompasses a static database and dynamic database, is known as knowledge base. Knowledge base has static database and a dynamic database. Dynamic database is nothing but working memory. Working memory apparently is the one which interacts with the user interface. And also it is connected, knowledge base and user interface both are connected to explanation module. This explanation module would describe, takes the user interface, takes the data from knowledge base, and provides some sort of explanation. For example, if a student write a answer in the exam, and teacher awards out of 10 marks question, teacher awards 5 marks, and also provides the explanation, comments. What sort of comments are provided? Saying that uh, although the answer is totally written, but the second part of the answer is not correct, and it is not giving the proper steps. Steps are placed arbitrarily, they are not organized. All these are the comments which teacher provides for this. Likewise here, why the expert system is taking this user query in which perspective, that explanation is provided by this module. And there are other modules which are inference engine. So we have done with user interface, knowledge base, explanation module. These three actually are directly related to this user. Mm, Essentially, this knowledge base is having a interaction with this expert system. Here and here, you see here and here. This one, this and this. This link shows the interaction between knowledge base and inference engine. This inference engine module has two components, inference and control. Inference engine is a module that infer. Infer means what? Draw new conclusions. Um, this user provides, um, say, symptoms from the knowledge base and through inference engine. When they both interact, and they both come to a conclusion. And this does not happen without the human expert knowledge. And this human expert knowledge is represented in this form of knowledge base. This human expert is a domain expert. If you ask a cardiologist information about orthopedic, maybe this orthopedic is specialized in his domain, cardiologist is specialized in his domain. Although both are doctors, both of them know the disease and medical conditions, medicines, symptoms, and all. But this one is more expert in his domain. He can give detailed knowledge about his area. Whereas this one gives the detailed and internal and complicated knowledge about his area. This human expert, through learning acquisition and learning knowledge acquisition and learning module, provides his expertise to this knowledge base, and here these two interact and gives out the output. This inference engine, this knowledge acquisition done. There are some special interfaces. These special interfaces would have a communication with inference engine. This special interface is concerned only with inference. All right, all these things are not that important for it. Just give something and obtain the inference. That is this. And inference engine also interacts with this case history, and this case history, because every case, uh, if not all, but there might be few cases which are totally unique in their nature. They are not common cases. For common cases, things will work out fine with knowledge base and existing knowledge. Suppose a unique case arrives, which is not actually looked upon or worked on at the time of this building base, that case history will be recorded, and that case history details will be acquired from this human expert through this knowledge acquisition and learning module. And likewise, this system is eventually an expert system specialized in a particular area. These are the modules and components of expert system, giving an overall architecture of an expert system. Knowledge base. We know that knowledge base, static knowledge consists of rules and facts, and dynamic knowledge, facts related to the particular consultation, that particular user's consultation. Inference engine is a process of searching to the knowledge base and deriving new knowledge. New knowledge is derived through inference engine, and this we know could be done using forward chaining method or backward chaining method. Example is given in forward chaining. Rule 1: if symptoms are headache, sneezing, running nose, sore throat, then patient uh, have cold. If symptoms are fever, cough, running nose, then patient has measles. All right, this is rule 1. Rule 2: based on what the values provided by the user at the interface, new inferences would be derived. Knowledge acquisition is done through textbooks, reports, case studies, empirical data, domain experts, and the primary and prominent source of knowledge is domain experts. Besides this, these are also used to obtain the knowledge. Case history, this is for dynamic database. It is created at the time of different consultation. It is used by learning module to enrich its knowledge base. Different cases. If it is existing, it's fine. If it is not, then it is to be learned. User interface of expert system allows user to communicate with the system in an interactive manner. This table shows a dialogue between user and the system. System says, "Do you have fever?" User, "Yes." System asks, "Do you have sore throat?" User replies, "No." Further, system asks, "Do you have cough?" User replies, "Yes." Subsequently, system asks, "Are you suffering from running nose?" User responses positively. The final question system asks, "Are you suffering from headache?" User responds negatively. So this is an interactive communication between a dialogue between the system and the user. Explanation module. Explanation module. It facilitates. It has explanation facilities to enable user to query the system. Here, explanation part is presented. System says, "I can infer measles using the rule if symptoms are fever, running cough, running nose, then patient has measles. Measles is concluded." This is actually inference. When this inference happens, user asks how. At that instance, explanation module, this is inference, explanation module come into picture. It says, since you have fever, running nose, cough, there is a rule which says that patient has measles. So measles is concluded for you. This is the explanation part. Special interfaces providing specialized activities such as handling uncertainty in knowledge. And these inferences form the major area of expert system research. All right. Expert systems versus traditional systems. The basic difference between expert system and traditional system is this expert system would solve a specific problem related expertise. In terms of problem related expertise, expert system is specialized to solve a particular problem. Traditional system is like a general purpose system. If it is compared with doctors, a traditional system would be a MBBS doctor, a general physician, whereas an expert system would be a cardiologist. What are the characteristics of expert system? Expert system exhibits expertise, specialized behavior, and it has symbolic reasoning. It can represent the knowledge symbolically, and it can reformulate, and it can reason. It has self knowledge because it has got that explanation module. It knows why it is taking that decision, and it can explain to others. It has got learning capability, and it learns from its mistake and it grows. For example, if a patient is diagnosed with measles, but patient does not have measles, right? The patient has typhoid, and patient, if this is informed to the system, the system would change its rule and learn from its mistake. Ability to provide training, because it can explain why it is taking that decision, therefore it can provide the training. Predictive modeling power, it has got uh, problem solving, uh, processing, and prediction capabilities. It can predict in the sense, Like it is predicting or saying that this may happen, that might happen, because it is an information processing module for solving problems. It can help users to evaluate new facts and understand their relationships. Evaluation of how to evaluate an expert system. Well, we can't say expert system is always giving the right answers or always giving the wrong answers. There should be some metrics to evaluate. So that one involves answering this question. Does the system make decisions that experts generally agree to? Whatever decisions are taken by the expert in a month, take log them and show that those to an expert, human expert. If human expert agree to that, it means expert system is doing quite well. Are the inference rules correct and complete? For instance, if we take example of this COVID, it has got several symptoms. If any one or two symptoms are missing, then it is not complete details of symptoms. Then the expert system might not uh, correctly infer. Therefore, it need to be understood whether it has got all the rules correct and complete. And this control strategy allows systems to consider items in a natural order that the expert prefers. Expert, a doctor, when you go to a doctor first ask symptoms, then ask whether you have conducted any laboratory tests, uh, finally prescribe medicine. If this same pattern is followed by the expert system, it is like behaving and exhibiting a human intelligence and way of solving the problem. But if it is not doing that, first it is suggesting medicine, then it is asking test and changing medicine, then asking symptoms and then changing medicine. It's not a right strategy to be followed. Are relevant questions asked? If a patient approaches the expert system, if a expert system is asking the relevant questions, then it can infer properly. If it is not asking a proper question and in an irritating manner posing questions, have you done shopping today? Hmm? If patient say, do you have fever? If patient affirmatively responds, and if system asks next, did you do shopping today? Then how patient gets irritated? Are the explanations given by ES adequate? Describing how and why, is explanation sensible? Does it make sense? If not, an expert system is not doing properly. Utility evaluation, is the system helping a user in a significant manner? Are the conclusions organized in a meaningful order? Is the system fast enough to satisfy the user? Is user interface friendly? Those would describe an expert system to be useful and to be, you know, better. Advantages and disadvantages of expert system. Advantages, actually, it first try to understand that it's not easy to build an expert system. It takes a lot of time and money, and to avoid costly and embarrassing failures, uh, one should evaluate the problem is suitable for expert system or not. If the expert system you are developing to solve a problem which is actually not that serious and does not involve any expert advice, then there is no meaning in developing that. Specialized knowledge problem, expert system should be developed for specialized knowledge problems, and there is a high payoff if if it is performing the intended task. Existence with cooperative expert system could be um used in complementary form with an human expert. Justification of cost involved in developing expert system. There should be some realistic assessment of the cost. If you are building a 1 million expert system and it is giving you the return in means not sufficient returns, there is no use of developing that. So it could not be justified. And which type of problem an expert system is trying to solve. This all must be addressed before developing an expert system. And the advantages of expert system is it helps in preserving scarce expertise. If suppose there is a doctor who is very specialized, who is famous all over, he has got lot of experience. If you are asking him questions and creating a knowledge base, it's like helping the scarce expertise, because you don't find such type of doctors knowledge everywhere in all doctors. It's like that. And it provides consistent answers for the repetitive questions. It fastens the pace of human professional. uh, Same thing, if it is routine task, then you can make use of an expert system. It holds and maintains significant level of information. It has got information. It provides high improved quality of decision making. And domain experts are not always able to explain their logic. um, However, expert system could explain. And it encourages organizations to clarify the logic. And it leads to major internal cost saving. It causes introduction of new products. Never forgets to ask a question, unlike a human. Sometimes human might forget to ask a question. Suppose, as told you that if there are 10 symptoms of COVID, and these days doctors are quite busy. If suppose they forget to ask two questions and ask only eight questions, then these two will be missed. However, when you feed the system to ask 10 questions, it mandatorily asks 10 questions. It will not forget. Disadvantages: unable to make creative responses. Of course, humans are intelligent beings, and they have common sense, and uh, they can respond creatively. Whereas expert system can't do that. It is sticking only to the knowledge that is fed to it, and there is no common sense, and it may cause errors. Sometimes everything cannot be obtained from the static database. Some things are dependent on the context and the situation at present, and it cannot adapt to changing environments. you know Again, in order to make it dynamic, process of building should happen. Automatically it cannot adapt. Change. What are the languages for ES development? Prolog is one language, programming in logic, and this was invented in 1970s. It is based on first order predicate calculus. Other languages like C++, Java, C could also be used to develop expert systems. This is not in your syllabus, rule based expert system. ES2 shells and tools, not there. Okay, next is truth maintenance system. I think truth maintenance system. Okay, this we will study tomorrow. Okay.